This is my intermediate algebra course. Today we're going to learn how to solve quadratic equations by completing the square. If you haven't done the homework completely and correctly from the last class, do that homework before watching this video. We can't solve quadratic equations by the usual methods. We can't add something to both sides of the equation, or subtract something from both sides of the equation, or multiply both sides of the equation. We have to use different methods because quadratic equations are more complicated than the basic equations that we've done. And in my beginning algebra course, we learned how to solve quadratic equations by factoring. And we're going to review that method today. But there are some quadratic equations that cannot be easily factored. And for these equations, you have to use the method that we're going to learn today also, called completing the square. Now, we're going to have to review quite a bit before we actually go into this method. And we're going to use the completing the square method to derive a formula that we can use to solve every quadratic equation. But before we do that, we have to learn that method by which we derive that formula, which is, again, the method completing the square. Now, when you actually complete the square without the formula, it's kind of a long method, and you really don't use that method in the real world. What you'll do is you'll either factor or you'll use the quadratic formula. But, and you might wonder, well, why are we going to learn this method if we don't really use it in the real world? Well, like I said, you have to learn this method because we're going to use completing the square to actually derive the formula by which we use to solve any quadratic equation. And today, we're actually going to solve quadratic equations where you don't really need the completing the square method, but we're just going to start with equations that are easily factorable because the numbers are going to be much easier on those equations. And what you'll find is that completing the square is not a difficult process, but what makes it difficult is the arithmetic that's involved. So we're going to start out really easy. So the first thing that we're going to do is we're going to review how to solve equations with squares. And when I say squares, I mean variables are squared. You see this x squared here? And you see this x minus 5 squared? The variables are squared. So the first thing that we're going to do is we're going to isolate the square. We're going to get it by itself. It's not by itself right now because the negative 2 is next to it and the 3 is next to it. And just to get us warmed up here, I'm going to go ahead and show all the steps. Even though I don't require you to show all the steps, what you can do is you can just isolate x squared immediately in your head. You don't have to show all the steps that I'm about to show. But again, I'm just doing this to help you get warmed up today. So we're going to subtract 3 from both sides, and we get negative 8 over here, and the 3's cancel out. We're left with negative 2x squared. And now I'm going to rewrite just to show the next step. Again, you don't have to rewrite. I'm just showing this so that you can be absolutely sure what's going on here. And it's important to understand that that's negative 2 times x squared. When a number is right next to a squared term like that, it means multiplication. So we have to do the opposite of multiplication, which is division. Again, we're starting off really small here. You might be thinking, I already know this stuff. I've already seen this. Well, I understand that, but review is sometimes really important in math. So just go along with me here. So now at this point, we've isolated the square. Okay, so now a lot of students would say, we're done. We solved it, right? Well, no, we're not looking for x squared. We're looking for x. We found x squared. So we have to get rid of this second power. So in order to get rid of that second power, we have to do the opposite of squaring. And the opposite of squaring is square rooting. We learned that in the previous class. And if you recall from my beginning algebra course, whenever you square root an equation, you have to put a plus or minus sign. Now, this can be kind of confusing for students because when you take the square root of some number, say, well, let's just use 4 because that's the number we're using here. The square root of 4 is 2, but it's not equal to negative 2. But here we're saying that it's both 2 and negative 2 by putting that plus or minus sign. So what are we doing? Is this contrary to what we learned in previous classes? Well, when you have an equation, you want any x value that will make that equation work. And so when you have an equation, we put the plus or minus sign, and the answer is going to be 2 and negative 2. But when you are just simplifying an expression like so, the answer is defined to only be positive. I know that's very confusing. But again, it all has to do with the idea that you're looking for all the values that will make the equation work. Both 2 and negative 2, if you plug them into this equation, they will both work. Therefore, they are both solutions. And it's very important to understand that what this means is that there are two solutions. Remember, plus or minus means two solutions. The answer can be positive 2 or it can be negative 2. So that is the solution. You can just leave it like that. And you're probably wondering, well, can't you break it into two parts and say x equals 2 or x equals negative 2? And the answer is yes, you can do that. But there's no reason to, because, we can just leave it with the plus or minus sign. Okay, so let's try another one of these. We're getting a little bit more complicated here. I'm going to put a divider. We want to isolate the square. That's this part in the numerator. So what I'm going to do is subtract 4 from both sides. And at this point, it's going to be a lot easier for you to understand what we're doing if we take this negative sign and bring it down. Remember, when a negative is on a fraction, you can put it in the numerator or next to the fraction line or in the bottom. And for this particular equation, it's going to be best for us to go ahead and put it in the bottom. That's the easiest way to interpret this expression. So now we're going to multiply both sides by negative 2. And now, at this point, we've isolated the square. So just like in the previous problem, once we've isolated the square, we have to get rid of that square because we want to get inside here to the x, but we can't get there unless we get rid of that 2 first. So we're going to square root both sides, which is the opposite of squaring. And that's going to get rid of the 2 power, and we're going to be left with x minus 5 is equal to plus or minus 4. So now we're going to add 5 to both sides, because we have to isolate x. And then we get 5 plus or minus 4. Now, again, remember, plus or minus means that 4 can be positive or it can be negative. So what we're going to do now is break the equation into two parts, and we're going to say, okay, what if 4 is positive? If 4 is positive, then one answer would be 5 plus 4, which is 9. And if 4 is negative, then another answer would be 5 minus 4. So that would be 1. And it's probably best to write or in between there. Okay, on to another of these problems here. I think we're going to do one more before you try one on your own. So we have the square. We want to isolate that square. It's not isolated because the 3 and the negative 2 are next to it. So at this point, I'm going to start going a little quicker. On the first problem, I showed every single step of the problem. In this problem, you can see I kind of skipped things. I didn't show everything because I want you to understand you don't have to show everything. This is intermediate algebra. So what that means is we're going up to a level where you don't have to show every step. And if you did show every step, it would get so tedious that it would just be impractical. So I'm going to isolate the square in one step. I'm going to add 2 to both sides and divide both sides by 3, and we get 25. So again, you might think, well, didn't you do kind of a lot there all at once? Well, that's okay. That's just basic operations. You should know how to do that. You might be a little bit rusty, but that's okay. You can still skip those 2 steps and just show the result after doing those 2 steps. So we want to get rid of the square at this point, so we're going to square root both sides. And keep in mind, the plus and minus, it goes on the side opposite the variable. I didn't mention that. And so the square root of 25 is 5, so we have plus or minus 5. And over here we have x plus 4. Now at this point, we're out of room. So what do? Well, don't panic. This happens a lot in school, remember. Sometimes you just run out of room. There's nothing you can do about it, so just make an arrow. And we're going to subtract 4 from both sides. And there's a couple different ways we could write this. We could write it like that, or we could write it like this. These two statements are exactly the same. It doesn't matter which one you write. Okay, so now we're going to break it into 2 parts, and x is equal to negative 4 plus 5, which is 1, or x is equal to negative 4 minus 5, which is negative 9. And those are the 2 solutions. All right, so now it's time for you to try one of these problems. You can take a screenshot of those if you think you need to go back to those. And so go ahead and try example 4. Remember, you want to isolate that square, get it by itself. It's not by itself because the negative 2 and the 3 are next to it. So try example 4, and when you come back, we'll do it together. All right, we're back. So I'm going to add 2 to both sides and multiply both sides by 3, and we get 9 is equal to x squared. And at that point, we've isolated the square, and we're ready to get rid of the square on the variable. And I always forget to move that over a little bit. Be sure to write legibly on all this stuff. So now we get plus or minus 3 is equal to x. And that is the answer. So if you got that answer, good job. Okay, try example 5. Remember, you want to isolate that square, and when you come back, we'll do it together. All right, we're back. So we're going to subtract 7 from both sides and divide both sides by negative 2, and we get 49 is equal to x plus 3 squared. And then we're going to rewrite. And we need to get to that x, but we can't get to the x unless we get rid of that power, the second power. So we're going to have to do the opposite of squaring, which is square rooting. And the square root of 49 is 7, and we get x plus 3. Then we're going to subtract 3 from both sides, and we get negative 3 plus or minus 7 is equal to x. And what this means is that x can be negative 3 plus 7, which is 4, or x can be negative 3 minus 7, which is negative 10. So there you go. If you got those answers, good job. Now, if you didn't get those answers, that's okay. Just go back and see what you did wrong. On to example 6. Go ahead and try example 6, and when you come back, we'll do it together. All right, we're back. So I'm going to add 3 to both sides and multiply both sides by 4, and we get 36 is equal to x minus 1 squared. And then we're going to square root both sides. And now the square is gone. Now we're ready to add 1 to both sides, and we get plus or minus 6 plus 1. And again, you can also write it as 1 plus or minus 6. It's the same thing. So we're now going to break it into 2 parts. And we have x is equal to positive 6 plus 1, which is 7, or negative 6 plus 1, which is negative 5. And there you go. So if you got those answers, good job. Okay, on to example 7. So now we're going to review factoring quadratic expressions. These are quadratic expressions, and we did this in my beginning algebra course quite a bit. Now, in previous classes in this course, we foiled binomial expressions. For example, x plus 3 times x plus 10. We used FOIL, which stands for first terms, multiply first terms to get x squared, and multiply outside terms, O is outside terms, to get 10x, and multiply inner terms to get 3x, and multiply last terms to get 30. Then you add the inner terms because they just happen to be like terms in this particular product, and I'll just put that over here because we're out of room, so that would be x squared plus 13x plus 30. And so again, we learned how to go from here to, and that's called multiplying the binomials or expanding the binomials, however you want to state it. If you multiply these, then you get this expression. But when you factor, you go the opposite direction. You start from here and you go to here. So that's what we're going to do. We haven't done that in this course yet, I believe. So we're going to begin by writing two sets of parentheses, or two pairs of parentheses. And we're going to ask ourselves, and here's how this works, what two numbers multiply to 8 and add up to 6? Now, there are two options for numbers that multiply to 8. There's 1 times 8, and there's also 2 times 4. And there's no other options when it comes to, rational numbers, and or when it comes to whole numbers. So both, again, 1 times 8 is 8, and 2 times 4 is also 8. So those are the two options because they both pairs of numbers, they multiply to 8. But the numbers also have to add up to 6. So is 1 plus 8 equal to 6? No, 1 plus 8 is 9, so that method is not correct. We can get rid of that. But 2 plus 4, is that equal to 6? And it is. So that is the correct factorization. We have to put x plus 2 and x plus 4, and that is it. That is the answer. That is the correct factorization. So there's really not much to these problems. If you remember my beginning algebra course, we did this, hundreds of times. So now let's try another one. We're going to put two sets of parentheses and write x and x, and what two numbers multiply to negative 8 and add up to 7? Now you have to be careful here because now we have a negative number. But, there's 1 times 18, there's 2 times 9, and there's 3 times 6. And I think that's it. So, but you have to be careful because one of these numbers in each pair is going to be negative, because a negative times a positive is a negative, and they have to be opposite signs. And so if we try, 3 and 6, again, we know that these numbers multiply together to get 18, so we've already tested the multiplication part. But now we have to add. So let's say that this is negative 3 plus 6, that would be 3. It's nowhere near 7. And if we switch the signs, we're just going to get negative 3. So that's not going to be the one. And, same thing with 1 times 18. That's not going to work either. So it's going to be 2 times 9. We just have to figure out which one is which. So we have plus 7, so we know that the bigger number is going to be the positive number. So 9 is going to be positive and 2 is going to be negative. Now, if you FOIL this back out, and by the way, I should have mentioned that, if you FOIL this back out, guess what you get? You get this expression. If you want to know why this works, you just FOIL this back out and you get the original expression. Okay, so let's rectangle that. Again, if you multiply these two numbers, you get negative 18. If you add the two numbers, you get 7, because 9 plus negative 2 is 7. Okay, on to a couple more of these before you try one on your own. So let's, again, write two sets of parentheses. And what two numbers multiply to negative 2? Well, there's really only one option when it comes to whole numbers, 1 times 2. And one number has to be negative, the other has to be positive. So here the negative kind of defeated, so the negative should be the bigger number. And so there you go. Now again, if you don't believe me, just FOIL that back out. X times x, x times 1, negative 2 times x, and negative 2 times 1, and then combine the inner terms and you'll get this. And so negative 2 times 1 is negative 2, and negative 2 plus 1 is negative 1. Now, don't be confused because there's no number here. Remember, if there's no number here, it's assumed to be either positive 1 if it were positive, or in this case, it's negative 1. So example 10, let's do another one of these. So 2 sets of parentheses as usual. Put your x, and we have to be really careful about the signs. These two numbers multiply to a positive, but they add to a negative. So what that means is that both of these signs have to be negative. And what do we have here? Well, there's a lot of examples for 40. There's 1 times 40. There's 2 times 10, or I mean 2 times 20. And there's 4 times 10, and a lot of different options, but we don't have time to try all of them. I know it's going to be 8 and 5. 8 times 5, negative 8 times negative 5 is 40, and negative 8 plus negative 5 is negative 13. So you can just try all those until you get the right answer. Okay, so now it's time for you to try. I'm going to leave those problems in the window. Go ahead and attempt number 11. Remember, what two numbers multiply to 10 and add up to 7? Put your 2 sets of parentheses and your x and try number example 11. And when you come back, we'll do it together. All right, we're back. So 2 sets of parentheses, x, and it's going to be 5 and 2. 2 times 5 is 10, and 5 plus 2 is 7. So if you got that answer, good job. Go ahead and try example 12, and when you come back, we'll do it together. All right, we're back. So we're going to put 2 sets of parentheses there, and x, and what two numbers multiply to negative 15 and add up to negative 2? That's going to be negative 5 and positive 3. Again, I could go through all the possible options here, but that would just take a long time, and you probably don't need me to do that. But in this case, there would be 1 times 15 and 3 times 5. Those are the only options that you can choose. And 1 times 15, with trial and error, you can see that it's not going to work. And, again, make sure that you understand that one number has to be positive and the other has to be negative, because you're multiplying the numbers to a negative. So try example 13, and when you come back, we'll do it together. All right, we're back. 2 sets of parentheses as usual, x, and it looks like it's going to be positive 9 and negative 1. 9 times negative 1 is negative 9, and 9 plus negative 1 is positive 8. So if you got that answer, good job. All right, for example 14, be aware of the signs. You need to pay really close attention to your signs. This number is positive, which means the numbers have to multiply to be a positive, but they have to add up to be a negative. So be very careful with that. You got to get the right signs in there, or else you're not going to get the right answer. So let's try example 14, and when you come back, we'll do it together. All right, we're back. So for this problem, both signs are going to be negative. That's what I was hinting at. And that is it. So if you got that answer, good job. Sometimes the binomials are the same binomial. Okay, so now we're going to solving quadratic equations by factoring. Now it's important to understand that in the previous problems, there were no equations. There were no equations here. Okay, we were only factoring quadratic expressions. But now we're actually going to equations, and the difference is, with these problems, you're given an expression and you're told to change the form of the expression. Okay, you had this form, you were told to change to this form. That's all you're doing. You're changing the form of an expression. In these problems, what they're asking is to find x. What are the x values? And you have an equation. You see that equal sign? In the previous problems, we didn't have that. We just had an expression. And we're told to solve the quadratic equations by factoring. So this is the method that we learned in previous classes, and we're just going over this to kind of review the whole idea of a quadratic equation. So we're going to solve these, and again, these quadratic equations, as I mentioned at the beginning of the class, quadratic equations cannot be solved by typical methods. We have to use special methods. And we're going to do the same thing we did in the previous problems. We're going to factor this quadratic expression, and that's going to help us find the solutions. So that's the special technique that we're going to use for these equations. Again, they're asking us what is x. We have to find x. So what we're going to do is factor that expression, and please, please be aware that even though you're changing the form here, you still have to write equals 0. We're taking this and bringing it down, and all we're doing is just factoring this expression. You must bring this down here. One of the most common things that students do is they forget to write equals 0. We still have our equation. So now, what two numbers multiply to 6 and add up to 5? Well, that is 2 and 3. You can think about it for a while if you want. And so the big question is, who cares? I mean, why do we care about this? Well, by changing the form of this expression to this, we can now see what the solutions are. We now know that x is -2 or x is -3. And you might be thinking, well, how do we know that? Well, you probably remember this from my beginning algebra course, so you don't really need to go over this if you remember this, but you don't need to listen to me explain it. But if you're a little rusty on the reasoning behind this, the reason that x equals -2 is an answer, for example, is if you plug in -2 here, and I'm going to move it over here just to show you what I mean. If you plug in -2, then you get -2 plus 2 times -2 plus 3 is equal to 0. -2, and we have to follow the order of operations here. Please understand, we must follow the order of operations. So we have to do the parentheses first. So -2 plus 2 is 0, and -2 plus 3 is 1. And anything multiplied by 0, 0 times 1 is 0, therefore it worked. You see, all we're looking for are the x values that make this equation true. We just proved that if you plug in -2 to this expression, it makes the equation 0, which means that -2 is a solution. See, that's all we're doing here. And you can use the same logic if you plug in -3. Anything that makes these factors 0, that makes the equation 0. One thing that really skips students' minds is that what you're doing here is you're taking this binomial and you're multiplying it by this binomial. That's the most important thing to understand with this technique. And because of that, if you can make one of these factors 0, either that factor or that factor, which is why we have two answers, then you can multiply a number by 0 to get 0. That's the whole purpose of this. Now, if you don't understand any of that, that's okay. You just have to follow. I mean, when I first learned this, I didn't understand any of this. I just followed the operations, and that's all you're required to do. And if you're wondering, why this works, you can go on, or you can, learn later on. But the most important thing now is just to figure out how to do the math. Okay, so let's try another one of these. I want to put a little divider here. And so, again, we're going to use that special technique. We're going to factor that expression. What two numbers multiply to 12 and add up to -7? Well, I'm not going to spend a lot of time figuring it out. I mean, it's just -3 and -4. And so now that we've changed the form of the expression, we know that x is going to be 3 or x is going to be 4. Now, notice the signs are opposite signs. That's kind of what I was getting to here. A lot of students will look at this and say, I don't get it. Shouldn't the answers be 2 and 3? Why did you put -2 and -3? Again, it all has to do with the logic where you're plugging in numbers to make these binomials 0. So you have to plug in the opposite sign. You have to plug in +3, so you get 3 minus 3 is 0. That's an important point. Again, a lot of this goes over students' heads. When you first learn this, all this stuff can be kind of overwhelming. But, if you took my beginning algebra course, which, again, is a requirement for this course, this should be very familiar to you. And if it's not familiar to you, that's a big problem. Because that means that you haven't taken my beginning algebra course. You need to go back and take that course before taking this course. So if this stuff is rusty, if you're rusty with this stuff, that's okay. But if you've never seen this stuff, that's not okay. That probably means that you haven't taken my beginning algebra course. So again, we're going to factor this expression. What two numbers multiply to negative 20 and add up to 8? I think that's going to be 10 and negative 2. And so, again, 10 times negative 2 is negative 20, and 10 plus negative 2 is 8. So now x is going to be equal to negative 10, or x is going to be equal to 2. And those are the answers. So again, it's very important to understand that this is different from what we were doing previously. Previously, we're just changing the form of an expression, but now we're actually using that to solve an equation. So now it's time for you to try. Again, write your two, I'll get you started here, write your two sets of parentheses, x and x, and then ask yourself what two numbers multiply to 24 and add up to 11. Go and attempt example 18, and when you come back, we'll do it together. All right, we're back. So it's going to be 8 and 3. Why? Because 8 times 3 is 24, and 8 plus 3 is 11. So why did we do that? Why did we factor? Well, we factored because it helps us to see the solutions. Now we know what the solutions are. Just by looking at that expression, we can see what the solutions are. And there you go. So if you got those answers, good job. All right, and if you're confused by this, that's okay. You really shouldn't be confused by this because this should be familiar to you. But if you're confused by this, that's okay because we're going to keep going with more of these problems. All right, try example 19, and when you come back, we'll do it together. All right, we're back. Remember, it's opposite signs. Negative 7 times 5 is negative 35, and negative 7 plus 5 is negative 2. So that's how we factored it there. And those final answers are x equals 7 and x equals negative 5. If you got those solutions, good job. Go ahead and try example 20, and when you come back, we'll do it together. All right, we're back. Don't have much room in here. What two numbers multiply to 4? I think that's going to be negative 4 and negative 1. Negative 4 times negative 1 is positive 4. Negative 4 plus negative 1 is negative 5. That might have been a slight challenge for some students. X equals 4 or x equals 1. If you had trouble with that, it's okay. A lot of students have trouble with that particular factoring problem. But now you know how to do it. Okay, so now we're going to some problems where you have a coefficient on the x squared term. Notice in all these equations, all these quadratic expressions, x squared didn't have any coefficient except 1. Of course, it's assumed to be 1. But in these problems, x has a coefficient, and factoring is going to be a lot more involved. So we're going to have to factor 2. If you factor 2, the only option is 2 times 1. So we're going to have 2x and 1x. But we don't have to write the 1 on the x. And then, of course, you have to factor this. Now, there's a lot of options for that. There's 1 times 12, there's 2 times 6, and there's 3 times 4. And, it might take you a while to figure out which one is which. Also, we have another issue here. We have a negative number here. So one of them has to be negative, the other has to be positive. So we might have to try 5 or 6 of these before we get it right. But I think I might have an idea of which option is correct here. I'm going to try 3 and 4. So if we foil that back out, and this is an important point. You're going to ask, how do we know that this is the right factorization? Well, like I said, you have to FOIL it back out. In the previous problems, you don't really have to FOIL it back out because you can just use those two numbers alone to figure out, if it's the right answer. But in this case, we have to FOIL back out. So the point I'm trying to make here is that these problems are not as simple as the previous problems because, the numbers that multiply to negative 12, they're not going to add up to negative 5. And that's the most important thing to understand. Really, 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 really need to understand that. When you have a coefficient here, it complicates things. These two numbers are going to multiply to this number, but they're not. I repeat, they are not going to add up to this number because you have the coefficient, and the coefficient complicates things. So that means that every time we try numbers here, again, we know it's going to be 2 and 1, so that's set up properly. We know it's going to be two numbers that multiply to 12, so that's set up properly. But we don't know for sure until we actually FOIL this back out. So if we FOIL it, we get 2x times x is 2x squared. 2x times 4 is 8x. Negative 3 times x is negative 3x. And negative 3 times 4 is negative 12. Then we add the like terms in the middle part. If you recall, those are like terms, and we get positive 5x. That's good news. We didn't get the exact right answer because we got positive 5x. We want negative 5x, but it's good news that we found that number because all that means is that we have to change the signs. Once we change the signs, we're going to have the right factorization. And again, you might have to try a couple of these, and it may not work. And I'll give you an example of something that doesn't work. Let's try 2 and 6. If you FOIL, you get 2x squared, and we set it up that way, so we don't really need to check that. You get 12x, and you get negative 2x, and then you get negative 12. Again, we already know negative 12 is going to be right. But then when you add these up, you get 10x. Our answer is not 10x. So again, you probably already know this because if you're taking this course, you know that beginning algebra is a prerequisite for this course. So you should already know all of this. But long story short, we have to change the signs. And now that we change the signs, now if we FOIL that out, we're going to get negative 5 in the middle. So that is the proper factorization. So as you can see, the process is a lot more complicated when you have a coefficient on the x squared term. You have to FOIL to check your answer. And I know that that's inconvenient, but that's just what you got to do with these problems. Now, over here we have x is equal to 4. But over here we've got a bigger problem. The reason that that x is equal to 4 is an answer is because when you plug it in here and subtract 4, this factor becomes 0, and then you have 0 times some number is 0. It makes the equation work. But there's a number that we can plug into x here that's going to make this factor 0, but it's not that simple to find the answer. And so again, we just want to know, what x value is going to make this factor equal to 0. So that's why I just set this expression equal to 0. And, you could do the same thing with the other side. You could say, x minus 4 is equal to 0, solve for x, and you'd find the x value that would make that equation 0. But we don't do that with that factor because it's just so easy to see it's the opposite sign. We may have done that in my beginning algebra course, but we can skip forward to this in this course. And so we have to solve this equation because it's more complicated. This is just a one-step equation. So it's so easy that we can do it in our heads. But here we have a two-step equation, so it might not be so simple. So we're going to subtract 3 from both sides of the equation, and we get 2x is equal to negative 3. And then we're going to divide both sides by 2, and then we get x is equal to negative 3/2. And so those are the two solutions. And I might as well just bring that down, I guess. And there you go. So as you can see, when there is a coefficient on the x squared term, as you can see for all these problems, unfortunately the quadratic is not as easy to factor. All right, so let's try one more of these. We're not going to do a lot of these problems because I don't want to dwell on them, and they're kind of annoying for students to have to deal with. We'll do more of these probably later on in the course. So what two numbers multiply to 3? Well, obviously there's just one option, 3 times 1. So 3x times 1x. Again, this should be familiar from my beginning algebra course. And what two numbers multiply to 10? Well, is 1 times 10. Whoops, that's a weird one. 1 times 10 and 2 times 5. Those are the only two options. So let's see what we can do here. Let's see. What's a negative 10? That's very important to understand. So let's try negative 5 and positive 2. One number has to be negative, the other has to be positive if they're going to multiply to negative 10. So now to check this, we have to FOIL. 3x times x is 3x squared. 3x times 2 is 6x. Negative 5 times x is negative 5x. And negative 5 times 2 is negative 10. Looks like we hit the jackpot. So 6x minus 5x is 1x. And that's good because we have the right sign. But like in the previous problem, it just so happened that we got the right number, 1, but we didn't get the right sign. We need negative 1. So all we have to do is just switch the symbols. That was just a coincidence that I chose that right number and then it was the wrong sign again. Again, if you choose some other, if you put the 2 over here and the 5 over here, it wouldn't work. So then you would have to switch the 2 and the 5 and try that, FOIL that out. So you might have to do quite a bit of foiling in your homework today. So now x, well actually we're going to have to do that equation. So 3x plus 5 is equal to 0. We want to find the x value that makes that equal to 0. And over here we know that x is going to be 2. We can just see that it's the opposite sign. And then here we're going to subtract 5 from both sides, divide both sides by 3, and we get negative 5/3, or x equals 2. And that is the final answer. And I'm just continuing that down there. Okay, so now it's time for you to try some of these problems. Try your best. Again, you may be a little rusty from my beginning algebra course, but that's okay. Use example 21 and 22 to help you, and attempt 23, and when you come back, we'll do it together. All right, we're back. So it's going to be 5x times x for the first part, and what two numbers multiply to negative 1? Well, there's only one option. It's positive 1 and negative 1. But we don't know if the negative goes here and the positive goes here, or if the positive goes here and the negative goes here. We don't know. So we're going to have to test it with foiling. So 5x times x is 5x squared. 5x times negative 1 is negative 5x. 1 times x is x, and 1 times negative 1 is negative 1. And you don't really have to write equals 0. Negative 5x plus x is negative 4x. And so, again, it looks like we, just by random chance, we got the right number, 4, but we didn't get the right sign. So all we have to do is just switch the signs. And there you go. Whoops. So that's the right factorization, but now we have to find the x values that make the equation work. As I said, this one's really easy. It's just going to be negative 1. But we have to add 1 to both sides and divide both sides by 5. I think that's the last time I'm going to show those steps because, that's just a 2-step equation. You should know how to do that by now. And so those are the two solutions. If you got those two solutions, good job. If you struggle with that a little bit, that's okay. You may be a little rusty on this. Don't get frustrated. Just see what you did wrong and fix your mistake. And let's go on to example 24. So go ahead and try example 24, and when you come back, we'll do it together. All right, we're back. So on this example, there are two possibilities, and I probably should have mentioned that before you did the problem. There's 2x and 2x, and there's also 4x and 1x, but I'm pretty sure it's going to be 4x and x because I remember doing designing this problem that way. So now it's very careful. You have to be very careful here because they multiply to a positive but add up to a negative. And what that means is that both signs have to be negative. A lot of students have trouble when both signs are negative. So, you know, for 9, there's two options. There's 1 times 9 and there's 3 times 3. So which one is it going to be? Well, I'm going to try 1 times 9. And we do FOIL and we get 4x squared minus 36x minus x plus 9, and negative 36x minus x is negative 37x. That's nowhere near negative 15. And so before I abandon those two numbers, I'm going to switch them. So I now have 9 over here and 1 over here. Now we're going to do FOIL again. That's f of FOIL. That's O of FOIL. That's I of FOIL. And that's L of FOIL. Negative 4x minus 9x is negative 13x. Well, it's closer, but it's still not negative 15. We need this number here. So at this point, I'm going to abandon the negative 9 and the negative 1 altogether, and I'm going to try negative 3 and negative 3. Now if we FOIL, we do f of FOIL, and O of FOIL, and I of FOIL, and L of FOIL. And, you know, I just want you to be aware that you don't really have to test F and L. You don't really care about that because we designed that so it would work. We only care about the inside part. So if you don't really want to write these green parts here, you don't have to. You can just do the O and the I of FOIL. So negative 12x minus 3x is negative 15x. So it looks like we got the right one. And so we're now going to set 4x minus 3 equal to 0. And we're going to set x minus 3 equal to 0. And, you know, we really don't have to do that. I mean, we can just say x equals 3. You know, it's obviously going to be 3 to make that factor 0. And then for x, we're going to add 3 to both sides, divide both sides by 4, and we get x is equal to 3/4. Bring this down, and we get x is equal to 3. And there you go. So if you got those solutions, good job. If you struggle with that a little bit, that's okay. You may be a little rusty from my beginning algebra course. You know, it may have been a while since my beginning algebra course. Okay, so that was all review. Believe it or not, that was all review from beginning algebra. We're now going to go on to the purpose of this class, which is solving quadratic equations by completing the square. So, as I mentioned at the beginning of the course, you know, again, we can't solve quadratic equations by the usual methods. We have to use special methods, and in the previous problems, the special method we used was factoring. Now, there are, like I said in the beginning of the course, or the class, there are some equations, quadratic equations, where you cannot easily factor them, and in that situation, we need to use this method, completing the square. But when you complete the square, you know, the arithmetic can be very difficult. And so we're going to start out with problems where the expressions are easily factorable, just so that the math is not so difficult, and that way you can learn how to complete the square without having to deal with a lot of difficult arithmetic. So here's what again, we just have a quadratic equation, and here's how you use the method of completing the square. You're going to take the number that has no x on it, and you're going to put it on the other side. And notice that I'm leaving a big gap here. I'm then going to rewrite it. And now I'm going to do what's called completing the square. What I'm going to do is I'm going to add 16 to both sides. And you might be thinking, whoa, wait a second. Where'd the 16 come from? Where'd you get that number? Well, we'll talk about that later on. But the reason that I added 16 is because it completes this. This is now a perfect square. It's what we call a perfect square. And you're going to see why that is. So first of all, let's do the easy part. Negative 15 plus 16, that's just going to be 1. But over here, we're going to factor this, just like we factored in the previous problems. Okay, so we need 2 sets of parentheses, and see if you can go ahead and factor that. I want you to factor this and see what that will look like. What 2 numbers multiply to 16 and add to 8? And you can pause the video if you want to. Now, you should have gotten 4 and 4. 4 times 4 is 16, and 4 plus 4 is 8. All right? Now, this is called a perfect square. And the reason it's called a perfect square is because both of these factors, both of these binomials, they're the same. They're both x plus 4. They're the same factors. Now, if you take, for example, let's just take a random number 3 and you square it, it's called a square because you're multiplying 3 by itself, just like you're multiplying x plus 4 by itself. Now, remember, if you have a square with side lengths 3 and 3, just again using 3 as an example, and you multiply those two, you find the area of the square. And, you know, that's why when you raise a number to the second power, that's called squaring the number, because you're finding the area of the corresponding square. And so that's pretty much what you're doing with the blue x plus 4s. You have a square, and one side is x plus 4, and the other side is x plus 4. And what we're going to do is we're going to write this in exponential notation. Let me change that back real quick. So we're going to change that to exponential notation. Now, a lot of students get kind of nervous when you change it to exponential notation. And the reason they get nervous is because usually you go from here to here. You go in the reverse direction. You know, we've taken this expression and we've changed it to this expression, and we've, you know, FOILed out. But in this class, we're going backwards. In this class, we're going from here to here. We can still do that, right? I mean, what does it mean to raise to the second power? You're just taking an expression and multiplying it by itself. That's all you're doing. So we're just going backwards. A lot of students are really confused by that, but there's nothing to be confused about. We're just going backwards. So at this point, you're probably thinking to yourself, who cares? I mean, why are we doing this? What's the point of this? Well, the reason that we did this is because here we have a complicated expression where the x squared and the x are separated. You know, whenever you try to solve an equation, you want to combine the x's. But we can't combine them because you have unlike terms. You have an x squared and an x. But now we've changed this equation so that it looks like this. And now the x is by itself. Well, it's not really by itself. It's not isolated, but there's only one. What I mean is there's only one x, you see. Here you have two x's, and you know, one's an x squared and the other's an x, so it's much more complicated than this. So now we're going to use the skills that we learned at the beginning of the class. We want to get to that x. That's the whole point of this, is to get to that x, but we have to get rid of that 2 before we can get to the x. So you know what's going to happen. And by the way, this is an equation with a square. So the first thing we have to do is isolate the square, but the square is already isolated. Okay, so now we're just going to square root both sides. Remember to put that plus or minus. And that gets rid of the square, the second power. And we have plus or minus square root 1, which is just 1. You know, 1 times 1 is 1. And now we just solve, so subtract 4 from both sides, and we get negative 4 plus or minus 1. And, you know, if 1 is positive, then one solution is negative 4 plus 1, which is negative 3. And the other solution is negative 4 minus 1. If 1 is negative, then we get negative 5. And so there you go. Okay, so that is the completing the square method. Now, notice that I didn't explain where this 16 came from. You're probably thinking, you know, where does that come from? Well, it's pretty simple. What you do to get that number, to complete the square, is you take the number that's next to the x and you divide it by 2. You always do two things. You first divide by 2, and then you take that number and then you square it. So if you take 8 and divide it by 2, you get 4, And then if you take 4 and square it, then that's 4 times 4, which is 16. That's how you get that number. And that's how you do it every single time. Now, I know what you're thinking. You're thinking, I can't remember that. Well, we're going to do a bunch of problems, and it's going to get to the point where you won't be able to forget it even if you tried. So let's try another one of these problems. We're going to go ahead and, like we did in the previous problem, we're going to take the last number that doesn't have an x on it. We're going to move it over, so we have negative 21. So we just move that number over to the other side. And now, just for your sake, we're going to rewrite it. We don't really need to rewrite it, but... And here's the big part where we're going to complete the square. Remember, we dealt with the 8 here. The negative 10 is going to tell us how to complete the square. And by the way, if you have something like, x minus 2 times x plus 5, you could you might be able to factor in something like that, but that's not a perfect square. That's a rectangle. We want factors that look the same as you did here, x plus 4 and x plus 4. That's a perfect square, not a rectangle. So what we're going to do is we're going to take this number, and we always do the same thing. We divide that number. It's always the number next to x, not x squared, but the number next to x. We divide it by 2, and we square it. So if you divide by 2, you get negative 5, and if you square that, you get 25. So that tells us that in order to complete the square, we have to add 25 to both sides. I know there's a lot going on here, but don't worry. You're going to do a lot of practice problems, and you're going to get used to this. So 25 minus 21 is 4. And now this is a perfect square. Go ahead and factor that. I want you to factor this in your head. You can pause the video if you want to. What two numbers multiply to 25 and add up to negative 10? If you said negative 5 and negative 5, you're correct. Negative 5 times negative 5 is 25, and negative 5 plus negative 5 is negative 10. So this is a perfect square. Why? Because when you factor it, both factors are exactly the same, and what that means is you can write it in exponential notation, and you can solve this resulting equation as you solved the equation with squares. Now, if you're thinking there's a lot going on here, you're right. This is probably one of the most sophisticated things that you're going to learn in the entire K-12 math curriculum, if not the most sophisticated thing, especially when it comes to the algebra and the arithmetic. So, I want you to understand that this expression up here, this equation, is the same as this equation. They're only in different, the expressions are in different forms. So if we solve this equation, that's going to be the same solution as this equation. So we're going to square root both sides. And remember, you have to put that plus and minus on the side opposite the variable. And we get 2 equals x minus 5. Then we're going to add 5 to both sides, and we get 5 plus or minus 2. And if we assume that 2 is positive, then 5 plus 2 is 7. And if we assume that 2 is negative, 5 minus 2 is 3. So those are the two solutions. So again, this method is called completing the square. And why are we using it? Because when we go into more difficult equations, we're not going to be able to factor. We can actually factor these problems, like I said, but we're using completing the square on these problems just to show you the method. Then we'll go into more difficult ones where you can't actually factor the equation. Then you have to use completing the square. All right, so let's do another one of these problems. I'm going to start going a little faster now because I don't want you to get bored. Notice that I left a gap there to complete the square. And so how do we complete the square? We take this number and we do two things with it. Always the same two things. We divide it by 2 and we square it. If you divide negative 12 by 2, you get negative 6. If you then square it, you get 36. And that is the number that you add to both sides to complete that square. That's why this is called completing the square. Okay, so now negative 32 plus 36 is 4, and this is a perfect square, so I want you to factor that. Factor that in your head. You can pause the video if you want to. But if you factor that, you should get negative 6 and negative 6. Negative 6 times negative 6 is positive 36. Negative 6 plus negative 30, or negative 6 plus negative 6 is negative 12. So now we're going to put those together. And, we want to get to, the x inside, but we can't do that unless we get rid of that square. So now we have x minus 6 is equal to plus or minus 2. And now we're out of room, but that's okay. We can just write a line and add 6 to both sides. So we get 6 plus or minus 2. And we end up with x is equal to 6 plus 2, which is 8, or x is equal to 6 minus 2, which is 4. And there you go. Okay, so we're going to try one more of these problems. And remember, repetition is extremely important, so we need to do a lot of these problems so you get the hang of this. We're going to go ahead and add 45 to both sides. Remember, you always take the number that doesn't have an x and you move it to the other side. So now we're going to rewrite, and we're going to complete the square. Now, how do we complete the square? We always take this number and do two things to it. We divide by 2, and then we square it. 4 divided by 2 is 2. 2 squared is 4. So that tells us we're going to add 4 to both sides. 4 plus 45 is 49. And this is a perfect square. I want you to factor that for me. Pause the video if you need to. If you got 2 and 2, you're right. So 2 times 2 is 4, and 2 plus 2 is also 4. So now we have x plus 2 squared. Again, just to be clear, 2 times 2 is this number, and 2 plus 2 is this number. So now we're changing to square notation, and we're going to square root both sides of the equation. And then we get plus or minus 7 is equal to x plus 2. We're going to subtract 2 from both sides, and we get negative 2 plus or minus 7 is equal to x. Now, if 7 is positive, it's negative 2 plus 7, which is 5. And if 7 is negative, then it's negative 2 minus 7, which is negative 9. Okay, so, you can take a screenshot of the problems that we did if you want to. Take a screenshot with your phone or something so you can refer back to these. If you use these, equations, it shouldn't be that hard to figure out what we're going to be, what you're going to be doing, and you need to attempt these problems on your own. Because if you don't do these problems on your own, then you're going to be lost when you do the homework. Okay, so try number 5. Remember, the first step is to get that 8 on the other side. And then remember, there's 2 things to do to complete the square. You need to take this number, divide by 2, and square it, and then add that number to both sides of the equation. But again, first take this and put it on the other side. Try number 5, and when you come back, we'll do it together. All right, we're back. Notice I'm leaving a space here. How do we complete the square? We take this number, divide by 2 to get 3, and then we square it to get 9. So that tells us what to add to each side of the equation. Negative 8 plus 9 is 1, and this is a perfect square. So if you factor it, like we learned in the earlier problems, it's going to be 3 times 3 to get 9, because 3 plus 3 is 6, and 3 times 3 is 9. So now we're going to change that to power notation. And then we're going to square root both sides, because we have to get rid of that square. And remember, you got to put a plus or minus on the side opposite the variable. So now we have x plus 3 is equal to plus or minus 1, because the square root of 1 is 1. Then we're going to subtract 3 from both sides. And if 1 is positive, then it's negative 3 plus 1, which is negative 2. And if 1 is negative, then it's negative 3 minus 1, which is negative 4. So if you got those answers, good job. If you got stuck, that's okay. But remember, you can use all these problems to help you. So try number 6, and when you come back, we'll do it together. All right, we're back. So we're going to take the 40, put it on the other side. That's always how we start. And just for your sake, you don't really have to rewrite again. But for your sake, I'm going to show another step here. And then how do we complete the square? We take this number, divide by 2 to get negative 7. Then we take that result, negative 7, and square it to get 49. So we're going to add 49 to both sides. That's how we complete the square. 49 minus 40 is 9. Whoops. And that is a perfect square. And if you factor it, you get x minus 7 and x minus 7. So now we can change it to power notation. And so we're going to square root both sides now. And we get plus or minus 3 is equal to x minus 7. And if we're out of room, that's okay. Now we're going to add 7 to both sides, and we get 7 plus or minus 3 is equal to x. And x can be 7 plus 3, which is 10, or x can be 7 minus 3, which is 4. So if you got those answers, good job. Okay, on to problem number 7. Again, you want to get the 80 on the other side. That's the first step. This problem might be a little harder to, well, it's not going to be that big of a deal. So go ahead and try number 7, and when you come back, we'll do it together. All right, we're back. Putting the 80 on the other side, and we want to know, how do we complete the square? Well, remember, you look at the number next to x, and it's 16. So we take that number, divide by 2, you get negative 8, and then take that result, negative 8, and you square it, and you get 64. And that's what you add to both sides to complete the square. 80 plus 64 is 144. You can use a calculator for that if you need to. And if you factor this, we get minus 8 and minus 8. Changing that to power notation, we get the following. And then we're going to square root both sides to get rid of that square. And remember to put your plus or minus. And you know, you could use the calculator for this. That's just going to be plus or minus 12. 12 times 12 is 144. Sorry for giving you that big number there. All right, so we're now going to add 8 on both sides, and we get 8 plus or minus 12. And then we have x is equal to 8 plus 12, which is 20, or x is equal to 8 minus 12, which is negative 4. So if you got those solutions, good job. Okay, go ahead and try number 8, and when you come back, we'll do it together. All right, we're back. I'm going to put the 99 on the other side. And then we're going to complete the square. But how do we complete the square? Well, we look to this number, as always, and we do two things to it. We divide by 2 to get 10, and then we take 10, the result, and we square it to get 100. So we're going to add 100 to both sides. 100 minus 99 is 1. And that's a perfect square, so we can factor it. And it's going to be plus 10 and plus 10. 10 times 10 is 100. And 10 plus 10 is 20. But again, notice that's a perfect square. Those two factors are identical. So we can put it in power notation. And then we can square root both sides. And we get plus or minus 1 is equal to x plus 10. Subtract 10 from both sides, and we get negative 10 plus or minus 1. And so we have x is equal to negative 10 plus 1, which is negative 9. Or x is equal to negative 10 minus 1, which is negative 11. So if you got those solutions, good job. All right, so now we're going to go to a slightly more difficult problem. It's not really that big of a deal. It's pretty much the same thing, but the difference with this problem is we have a coefficient here on x squared. You cannot complete the square unless you get rid of that coefficient first. Now, in all the previous problems, we didn't have a coefficient on the x squared term, you see, except when we were factoring. When we factored over here, used the factoring method, then we had coefficients. But now we're using completing the square, so we have to learn how to complete the square with the coefficient there. And you know, it's very simple. All we're going to do is just get rid of that coefficient in the first step. So I'm going to rewrite, and I'm going to get rid of that coefficient. And so this 2 is multiplied into the x squared. So how do I get rid of that 2? Well, you do the opposite of multiplication. You divide by 2. Now, in my beginning algebra course, very, very early in the course, we learned that if you divide a polynomial by a monomial, which is what we're going to do, we're going to divide both sides by 2, then what you do is you divide each term by that monomial. So 2x squared divided by 2 is just x squared. That's why we did that, because we got rid of the 2 in front of the x squared term. 12 divided by 2 is 6, and the x just stays there, and 16 divided by 2 is 8. Now it's very important to understand, 0 divided by 2 is just 0. You know, anything, you know, 0, when you divide 0 by something, it doesn't do anything, it just remains 0. Okay, so at this point, we've gotten rid of that 2, and now we're just ready to do the same thing we did in the previous, 6, 7 problems. Again, we're supposed to solve by completing the square. We could actually factor, but again, that's not what this part of the class is about. We need to learn how to complete the square. So we're now going to rewrite as usual. Again, you don't really have to rewrite this step, but I'm just doing this to show you. So now we're going to take 6 divided by 2, we get 3, square 3, we get 9. Add 9 to both sides, negative 8 plus 9 is 1, and that's a perfect square. X plus 3 times x plus 3, and we're out of room, but that's okay. We can go up here, and we're going to combine those x plus 3's to power notation. And of course, we're going to then get rid of that power by square rooting both sides. Subtract 3 from both sides, and we get negative 3 plus or minus 1. And if 1 is positive, we have negative 3 plus 1 is negative 2. And if 1 is negative, we have negative 3 minus 1, which is negative 4. So if you got those answers, good job. Okay, on to number 10. Let's try one more of these together before you try one on your own. And you can see that there's really no difference with this problem and the previous problems. The only difference is you had to divide by 2 to get rid of that coefficient. And you may notice that I'm making these numbers really easy for us. In the next class, the numbers are not going to be so easy. All right, so for number 10, we have to get rid of that coefficient before we can complete the square. That's extremely important to understand. We cannot complete the square like we did in the previous problems until we first get rid of that coefficient of x squared, the negative 3. So we're going to divide both sides by -3. And 0 divided by -3, that would just be 0. That doesn't really change anything. -3x squared divided by -3 is x squared. That's why we did that. 30x divided by -3 is -10x. And -48 divided by -3 is +16. Now we just complete the square like we did in the previous problem. So we're going to take the 16, put it on the other side. And now we're going to complete the square. And again, this is the step that you don't really have to show if you don't want to. You don't have to rewrite this. You can just go ahead and complete the square on this side. I would use different colors if I were you. That would make it a lot easier for you to understand what's going on. But if you don't have other colors, that's fine. Take -10, divide it by 2 to get -5, square -5, and you get 25. I'm going to move this over a little bit. You want to try as hard as you can to make your writing legible, or else there's no point in even writing it at all. 25 minus 16 is 9, and that's a perfect square. We designed it that way to be a perfect square. So it's going to be -5 minus 5. And we can put that into power notation. And now it's in power notation. We can square root both sides. And we get x minus 5 is equal to ±3. And therefore x is equal to 5 ±3. And it looks like we're going to have to move this down a little bit. And if x is, or if 3 is positive, 5 plus 3 is 8. If 3 is negative, then 5 minus 3 is 2. So again, it's not really that much different. It's just that initial step where we have to get rid of that coefficient of x squared. Okay, so now it's time for you to try, and you can use the previous problem if you want. So go ahead and attempt number 11. Again, the first thing you have to do is divide both sides by 4 to get rid of that coefficient. We cannot complete the square unless we get rid of that coefficient. So try number 11, and when you come back, we'll do it together. All right, we're back. We're going to divide both sides by 4 to get rid of that coefficient. And we get x squared minus 8x plus 7 is equal to 0. And then we're going to complete the square by putting the 7 on the other side. And notice I left a big gap there to complete the square. So how do we complete the square? We divide this number by 2 and then square it, and we add that resulting number to both sides. -7 plus 16 is 9, and that's a perfect square, so if you factor it, you get x minus 4 times x minus 4. And then you can put that in power notation as usual. And of course, we're going to square root to get rid of that square so we can get into those parentheses to get to that x. So x minus 4 is equal to ±3. Then we're going to add 4 to both sides. And we get 4 ±3. And if x is, or if 3 is positive, we get x is equal to 4 plus 3, which is 7. And if 3 is negative, we get 4 minus 3, which is 1. So if you got those solutions, good job. All right, I think we have one more problem for the day. I believe one more problem. Go ahead and try number 12. I'm going to leave these in the window for you. And when you come back, we'll do it together. All right, we're back. divide both sides by -5. And we get 0 is equal to x squared plus 4x minus 5. And now we're going to complete the square, add 5 to both sides. How do we complete the square? Well, we take the coefficient of x, divide by 2, square it, and that number must be added to both sides of the equation. I move that over a little bit. Okay, so we're out of room, but that's okay. That happens a lot. Don't get nervous about that. 4 plus 5 is 9. And we have x plus 2 times x plus 2. Put it into power notation. And square root both sides. And we get plus or minus 3 is equal to x plus 2. And it looks like we're kind of out of room here, but we can kind of just we can just go out to the side, I guess. So -2 plus or minus 3 is equal to x. And we can do this arrow technique again. What we can really do is just make some room up here. It's probably best. And move that up one line. See if that helps a little bit. Alright, and so now x can be -2 plus 3, which is 1, or x can be -2 minus 3, which is -5. If you got those solutions, good job. That's very good. So that was the class today. Let's go ahead and take screenshots of all the work that we did to help you with your homework or to study for tests. So this is screenshot number 1 and screenshot number 2 and screenshot number 3 and screenshot number 4 and let's go and look at the homework. Here's the homework. Get a screenshot of that. And remember, your homework has to have 4 characteristics. It has to be complete, correct, neat, and in correct chronological order in your binder. And remember, if you don't do the homework, it's a 100% guarantee you're going to learn absolutely nothing in this entire course. And also remember to number your problems and to circle the problem numbers and rectangle all your answers, and you're going to need to show all the work. You might be able to skip 1 or 2 steps, but you need to show most of the work to solve these problems. And also write your name, the date, the course title, intermediate algebra, and a title for the paper, and so on and so forth. So get that homework done, and I'll look forward to seeing you in the next class.